Hello my friend, this is Jono, and today I want to talk to you about Linux. Now, Linux is the most successful open source project ever, and since it was born in 1991, it has had a huge impact in the world. Pretty much any device you're using, whether it's your cell phone or a computer or a smart speaker or one of those weird IoT devices that counts eggs in your fridge, whatever, it's probably going to be running Linux. But here's the question, there are hundreds of thousands of open source projects out there, so what is it about Linux that's made it so successful? Well, in this video I'm going to walk through 6 key reasons that I think have defined the success of Linux over the years, okay? But before we get into that, I want to first of all give you a sense of just how big Linux has become. I'm going to move over to the old computer here, and I found this interesting article on hostingtribunal.com. Never heard of it. But they've got this big page with loads of Linux statistics on it. But the key ones are here at the top, okay? So in 2021, the lines of code submitted to the Linux Git repository. Git, by the way, if you're unfamiliar with it, is a tool that is used to kind of manage contributions into a piece of software. It is essentially the central piece of GitHub. But the number of lines of code have reached 27.8 million lines. Now, I'll be honest with you, I don't like measuring open source projects based upon lines. I think it's kind of stupid. And the reason why is because one line of code could be a comment, or it could be, alternatively, an incredibly long line of code that implements a really complicated algorithm. But, you know, lines of code is a pretty decent way of measuring the size of something, and I think we'd all agree that 27.8 million lines of code is quite big. All right, let's move on to the second one here. In 2021, 100% of the world's top 500 supercomputers run on Linux. Pretty impressive. Out of the top 25 websites in the world, only 2 aren't using Linux rather. I'm curious how they define the top 25 websites in the world, but I'm pretty sure my website not on the list. 96.3% of the world's stop that. 96.3% of the world's top 1 million servers are running on Linux, and 90% of all cloud infrastructure operates on Linux, and practically all the best cloud hosts use it. Curious what this link goes to in terms of best cloud hosts. Is this some kind of affiliate program? Hostingtribunal.com? Well, no offense, but I ain't clicking on your link, okay? But I think we can all agree that Linux is huge, and it's had a massive, massive impact, all right? So, as I mentioned earlier on, there are hundreds of thousands of projects out there, open source projects out there. So what is it about Linux that has been so successful? So I'm going to move over to the board, and let's get these 6 reasons down, okay? I'm going to walk through each of these one by one. All right, now, reason number 1, I think this is really important, is Linux solves a real world problem. Trying to write here without you seeing my incredibly bald head up there. Now, as I mentioned, there are loads of projects out there, and only a small subset of these projects are successful, right? You take projects like Python or Ubuntu, Kubernetes, NPM, Fedora, all kinds of different projects out there. But one of the critical requirements for an open source project to be successful is that it needs to provide some value to other people, right? Like you could go out there and create an amazing piece of code that only you need. Like you could create an open source project that manages your specific devices in your specific business or your specific house, but it wouldn't be generally useful to other people. But when you identify a topic that other people are interested in, that gives you the opportunity to build some growth here, okay? A good example is Kubernetes. Back when Kubernetes first came out a few years ago, there were a lot of people out there who were trying to figure out a more efficient, more reliable, and more secure way to put applications on the internet via the cloud, okay? Kubernetes came along, it signaled a lot of interest, and then it created this huge project around Kubernetes and the CNCF, okay? Now, to talk about Linux, to understand Linux, we need to go back in time to 1991, and this is what computers looked like back then. This is actually a list of Unix workstations. I'm going to talk about Unix in just a second, but it's important to remember the context around technology back then, especially for those of you who are younger. You know, today, technology is available pretty much everywhere. We've got it on our phones and our pockets. If you want to do anything, you can largely do it in a web browser these days. Most of us are tending to keep things online in SaaS services, and we're using services like Google or Salesforce or or other applications, okay? But back in the early 90s, it was very, very different, okay? You had a computer and it ran an operating system. The web didn't really exist very much for most people. So when you went out and bought a computer, the choice of operating system that was running on it was really important. And there were a few options, right? You could get MS-DOS by Microsoft, you could get Windows by Microsoft, you could get Apple's operating system, or you could use something called Unix, which was created by much larger companies like, well, larger companies, not necessarily much larger companies, but large companies like IBM, and it was generally used in commercial settings. You know, banks and large businesses were using Unix to manage their data processing. And how they were working with their particular projects and customers, okay? So Unix wasn't really something that consumers used at all, okay? And part of the reason why Unix wasn't really used by consumers is that you typically needed special computer hardware, like you can see over there, okay? Now, the downside of this era of technology is that a very small number of companies really kind of controlled what we were using, right? Because if Microsoft were building MS-DOS and Windows, that would influence which hardware companies were going to be building computers, right? Because they would need to be running those particular types of operating systems. Okay, so it was like a small number of big companies working with a small number of big companies, and that dictated what we had available to us in terms of computers and technology. You know, cell phones didn't exist, you know, tablets didn't exist, the internet didn't really exist in a consumer setting, okay? Now, the reason why I'm mentioning this little history lesson is that back in the early 90s, what Linus created, Linus Torvalds, the creator of Linux, created with Linux was a version of Unix that you could run on a normal computer. So most of us back then were running computers that ran these processors. It was a 286 or a 386 or a 486, these earlier stage Intel processors, and just general components that were plugged in together into a desktop machine, or in some cases a laptop machine, okay? But Unix wasn't generally available for those computers. Most people couldn't use it, and if there was, I think there may have been some versions of Unix available for those computers, but they were very, very expensive and you had to spend a lot of money on them. Now, for technology people, Unix was kind of seen as a bit of a gold standard, right? It was the most advanced, the most complex, the most comprehensive operating system that was out there. And a lot of people learned Unix when they went to university, and they'd be using Unix in computer labs. You know, when I was at university, there was a whole lab of Unix machines that I ended up using. When I did work experience with my brother at a council, he was managing the Unix systems for the local council, these big mainframes in these big rooms. So the idea of taking that operating system and running it on your little computer at home, and when I mean little, I mean it was this big, right? But your little computer at home was incredibly exciting, right? So the idea of a free version of Unix that was running on your computer was interesting. But there was already a free version of Unix around called Minix, but people didn't really use it. And what was exciting about Linux is that it was open source, and it created a real buzz around it where people started contributing to it. And I'm going to explain in some of these other reasons why it created that buzz, okay? But the reason why we were even getting out the gate with Linux, the reason why people were even paying attention to this, you know, this Finnish dude making this thing called Linux, was because it solved a real problem. It provided something that other people were interested in. And interestingly, of course, back then, by definition, the only people who are interested in Unix, especially in 1991, are technical people. And technical people generally can write software, especially back then. Right? So Linux attracted the ultra nerds, right? The ultra nerds sweeped in. They were like, wow, have you seen this thing that this Finnish dude's creating? It's really cool. You can download the code, you can compile it, and you can run Linux on your computer. That's amazing. Oh, I'd like to go and create a feature and add this into Linux. And boom, off you went to the races, okay? So this right here, it might seem obvious, but it's a really, really important reason why Linux has been so successful. And as you think about how you build open source projects, always ask yourself the question, like, what is the likely size of my audience that are going to be interested in this? I'm pretty sure that Linus didn't go and sit down and map out the total addressable market or anything like that. He built it because it was a fun project and he thought other people would be interested, and he shared it, okay? And take the same kind of approach. Are there going to be other people interested in my own open source projects, okay? All right. Let's now move on to the second one here. And this is that Linux was and continues to be openly licensed. Now, I'm going to be honest with you. I don't particularly like talking about licenses on YouTube because it's going to attract a certain subset of people who are going to go into the comments and just start yelling at me that I haven't perfectly articulated the legal argument for this specific license, or that I'm a horrible person because I don't agree to some ideology around licensing, right? If you are one of those people, you are not welcome in the comments. Go and annoy somebody else, okay? I'm not interested in anything that you've got to say. I've already had these arguments a million different times, okay? My goal here in talking about the open licensing around Linux really is to just explain why this was such a critical piece. Now, what I'm going to do is I'm going to write the license down here in blue so we can... I've already screwed up. Hang on. Oh, what a mess. What a mess, Jono. Okay. All right. So the license that Linux is under is called the GPL. Okay. This was a license that was created by Richard Stallman, and a very, very, very important part of open source and free software history. Back in the early 90s when Linus created Linux, there weren't a lot of licenses out there. There were some available licenses, but today we've got hundreds of different free software and open source licenses. But back in the early 90s, the GPL was kind of the hot new thing, right? Kind of. Which is kind of funny to think about because the GPL feels like it's been around forever. But what's so special about the GPL is that it basically states that if you download a piece of open source software and you make a change to it, then your contribution, your piece of code that you create the change with, has to be licensed also under the GPL under the same terms and conditions. So it meant that anybody who downloaded Linux and improved it in some form, their contributions were also licensed under the GPL. And what that meant was that it created this kind of viral effect of goodwill, if you will. Lots of developers came in and started building additional features and modules into Linux. And because all of those were licensed under the GPL, it meant that everybody felt like they were on the same playing field. Now, this, I think, was a great decision for Linux back then, for Linus to make with Linux back then. Linuses and Linuxes are very confusing. These days, if you're licensing another piece of software, let's say you're building a piece of infrastructure software or a web application, whatever, there are many other considerations to make. So for example, the GPL is not good if you want to build a business where you have a piece of open source software and then people create, closed source proprietary plugins, things like that, because the GPL is not compatible with that. So there are limitations with the GPL. But what it did is it created this important social contract that was wrapped around Linux that created a level playing field for everybody where people could come in and start contributing, okay? Now, this was, again, a really wise decision, and I think one of the reasons why Linux has been so successful over the years is because of the GPL, right? And this is where the discussion of licensing will end, to avoid the weirdos coming out and attacking me in the comments. I'm not scared of other people's opinions. I'm not scared of people sharing a conflicting view of mine. I just feel like I've wasted enough of my time on licensing, enough of my life on licensing, I'm tired of it. I'm so tired of it. Anyway, let's move on, shall we? Let's move on. All right, number 3 is simple contribution model. Now, when you create an open source project, and you want other people to be able to contribute into that project, you need to make it easy for people to be able to do that, okay? If people have got to download the code and then they've got to jump through a whole load of hoops to get their contribution into that main code base, you're going to lose people, right? So simplicity is the spice of life. And these days, contributing to open source is easier than ever, right? First of all, we have a lot more education and training available to people around how to contribute to open source. But you've also got platforms like GitHub and GitLab, where you can go and fork a project, or you can clone a project, you can take that code, you can make a change to it, and then you can submit it through something like a pull request mechanism in GitHub, where the changes are added. It's easy to see the diff in the changes. It's easy to have a conversation about changes or improvements that need to be made. And then it's easy to merge that into the main code base. But back in the early 90s, that didn't exist. There wasn't any Git. There was version control, okay? There was CVS and Subversion. I can't exactly remember when Subversion came out, but maybe that existed. So there was some version control. but it wasn't anywhere near as comprehensive as we have today. But the reason why I'm mentioning this as this simple contribution model is that back then and to this day, if you wanted to make a contribution into Linux, you simply sent your patch to an email list, right? So you downloaded the Linux code, you made your change that added a feature or fixed a bug or whatever. You used a tool called diff to spit out the differences between your version of the code and the original version of the code, and then you sent that patch to the email list for the Linux project. It will be reviewed and then it will be merged in, okay? Now, if I go over to the computer, you can see here today, there's really simple comprehensive documentation for how to do this, okay? And this existed back in the old days in like little text files that people would use, but this just walks through step by step how to go and create a patch and get it merged in. And even though the kind of the contributor model back in those days was really simple, you send a patch to an email list, okay? The Linux communities continue to simplify how contributions get made. All of this great documentation is in here, details about how all these different subsystems are managed and operated. It's really solid, okay? And the one thing I do want to emphasize here is that Linux is really unusual when it comes to how open source is built. You know, a lot of people who are new to open source will say, okay, we're creating an open source project. We should go and learn how Linux is created because that's the most successful open source project, and then we can copy how they do it in our project. Don't do that. Do not do that, okay? The way the Linux kernel community operates is very unusual, and it doesn't scale out and map to newer open source projects, okay? A lot of the reason why the Linux communities operating, the Linux kernel community is operating in the way it is because they've just been doing this way for so many years, right? So there's a historical precedent here. But today I definitely operate in a very different model. However, the fact that it's still so simple to contribute into Linux is a very powerful reason why Linux has been so successful, okay? All right, let's now move back to the board. We're going to go on to number 4 here. This one's going to be interesting, okay? If the license weirdos didn't come out of the woodwork to come and get angry, then this one will, okay? Corporate involvement. Yeah, part of the reason why Linux as a open source piece of software, as a open source piece of free software has been so successful is because companies have been involved, okay? Now, what do I mean by this? Well, first of all, when Linux was created, and it was, you know, this free Unix style kernel, it meant that companies were building technology. Well, let's say they were building another piece of software that needed a kernel, such as an operating system. If you think about companies like Red Hat or Canonical with Ubuntu or SuSE with SuSE Linux, that meant that they could then go and take that piece of software and use it in their products. Okay, you know, I mean, when we talked about the GPL earlier on and how it enables people to build free software together, there is no rules restricting selling GPL software. Okay, that's very important to state. You can sell GPL software. There are just limitations in creating non-free bits of code that sit inside of GPL projects. So companies who were building operating systems and software platforms could use Linux in their products, but it also meant that people who were building hardware could. If you were building a computer, or you were building an embedded device, as we used to call them back then, that was anything that wasn't a typical desktop computer was referred to as an embedded device. And we went through all kinds of different embedded devices over the years, like netbooks and various mobile form factor devices. And they could use Linux, right? They could take Linux, and where it didn't work, they could make contributions to get their device running, and then they could contribute those contributions back into the Linux kernel community, and this kind of spread the workload, okay? So lots and lots and lots of companies started using Linux as a piece of software, as a tool within their products, and that was fantastic. You know, back in 2000, IBM invested a huge amount of money. I forget exactly how much it was. It was like $500 million or $1 billion, something. I forget what it was. Don't quote me on this. But they invested a huge amount of money into Linux because it was playing a fundamental part of how they were starting to operate their business, okay? However, where this gets really interesting was the number of people contributing into the Linux kernel, okay? So I'm going to move over to the computer here. This is a report that the Linux Foundation puts out, and this basically shows all kinds of statistics. This is the kernel history reports, okay? Now this is going up to 2019, so the data's a little bit old, but look at all of these different companies who are contributing into Linux, okay? And the number of commits and their percentage. Intel, Red Hat, IBM, SuSE, Linaro, Google, Samsung, AMD, Texas Instruments, Oracle, Broadcom, Huawei, Mellon, all kinds of different companies, okay? And the reason why they're contributing into this is because Linux has become this shared code base that offers huge amounts of value, and you know, the amount of value they can extract from Linux versus the amount of value that they have to invest into Linux is far outweigh. The value that they extract is far outweighs the amount of the cost to them to invest in it, okay? So essentially, you know, let's say you've got Huawei and they're building a device and they need to run Linux to power a particular chipset, and Linux doesn't support that chipset, right? So Linux will power everything else on that device, and they can use it for free, and they can hire people who know how Linux works and all those kinds of different things, okay? But if they need to get that little chipset working, then they just need to pay an engineer or a couple of engineers to go and build that and contribute that back into the Linux kernel, and then boom, they're good to go, okay? So what I find so amusing about this is that when we start getting into these ideological debates about free software, there are some people out there that believe that any corporate involvement in open source and free software is a bad thing. And those people are wrong. Like, this is not that I think they are wrong. They are 100% incorrect about this, because we would not have, I promise you this, we would not have the Linux kernel we have today if it wasn't for all of these companies getting involved, okay? Now, the reason why this works is because the foundations of the Linux project, the way it's licensed, the way it's managed by Linus Torvalds, all the subsystem maintainers, which I'm going to get to in a second, it's the right foundation to equalize the playing field for all of these different corporate entities to kind of come in and have an impact, okay? But it's really, really, really important that we identify the value of companies contributing into open source and free software, okay? All right, let's now move over to our fifth one here, okay? Active maintainers and leadership. Okay. So everybody's familiar with Linus Torvalds. If you're not familiar with him, he's the guy who started Linux, you know, back in 1991. I've known Linus for many years, and what I love about him is that he's a genuinely decent person, and he's as passionate about building kernels and building software as he's ever been. You know, a lot of people, when they start out earlier on in their career, they may focus on building technology, and then it's kind of funny here in Silicon Valley. A lot of people go down a standard pathway, which is you start out as a developer, then you go and work for a startup. They have an app that they have a sale, you make a bunch of money from equity. Then you go and start your own company, and then you have a sale, you make a bunch more money. Then you go and work in an executive position for a really big company, like a Samsung, or maybe not that big, but you know, a large tech company like a GitLab or a GitHub or something like that. And then you go on and you become a VC. That's kind of the Silicon Valley pathway, okay? And what I love about Linus Torvalds is that he's always maintained his passion about building kernels. He's not being interested in being a leader in a big tech company. He's not interested in being a VC or anything like that. He just loves building technology and working with his peeps in the Linux kernel community, okay? So he specifically, you know, when we think about Linus, has been a very, very important driving force in the community. And I think he should be credited for that, you know? Sometimes he's had a sharp tongue with people. And part of the reason why he's maintained quality in the kernel community is that he doesn't accept bad code. There was a short period of time where, you know, his sharp tongue was getting a little too sharp, and he made some changes, you know, to adapt, and credit where credit's due to him for that. But he's a really genuinely decent guy who loves everything about building a kernel. But importantly, he can't do it alone. right? When you've got 27 point, what was it? Hang on, forget how many lines of code it was. 27.8 million lines of code. That's a lot of work for one person. So what he's ended up doing is essentially staffing the Linux kernel world with a bunch of generals, right? Think of him as the commander and the generals are the maintainers. And the maintainers will maintain chunks of Linux. So Linux is broken into lots and lots of individual modules that will provide support for webcams and devices and SuSE controllers. SuSE, wow. It's a blast from the past. Is that even a thing anymore? Put in the comments, is SuSE a thing anymore? Some of you are typing in, what is SuSE? But yeah, I don't know. Is there support in the kernel for the parallel port? God, how old am I? Jeez. I'm sorry, everyone. I'm gonna have to have a cup of tea to get over that moment. Anyway, so where was I? What was I talking about? Yeah, we've got these generals who are maintaining these different modules, okay? So if I go to the computer, where was it? This one. Here we can see a big list of the maintainers. And look at all these. I mean, this is a good example, like network driver, Stefan Klasset, another network driver, David Dillo, all of these different people. And this is a very, very, very long list. I'm going to talk to you while I'm scrolling this. All of these people are maintainers of chunks of code within the Linux kernel, right? And what they do is they take responsibility for making sure that these different components in the kernel are up to date, they've got security patches applied to them, they're reviewing and bringing in contributions. So what's happened here is Linus, through these maintainers and through his overall oversight in the project, has maintained an enormous level of quality throughout Linux as it's grown across the last 20 odd years. Not 20, how long, how many years? 1991, 2001, geez. How many years have we been doing this? Many, many years. 20 years. I can't do maths. This has been a long day, so just forgive me, all right? Anyway, so that's one of the reasons why Linux has been able to grow so significantly, is that it's been able to scale up. This wasn't something that Linus set out with. He didn't create this maintainer model right out the gate. He started by building a kernel, and then as interest and growth continued to kind of come in, then he'd anoint these different people who were maintaining these different parts of the community, and boom, we've been able to grow much more significantly. All right, now let's move on to the sixth one, and this is a flexible release model. Now, you know, when you've got a project that operates as quickly as Linux, when you've got 27.8 million lines of code, it's changing every single day. And that's great. And we can talk about these amazing statistics, but that can present a problem for different people who want to use it, right? Like if you are a company that's building a product, let's say you're building, I don't know, a smart speaker, and you want to use Linux to power that smart speaker. You can't go and update that smart speaker every day with changes from the Linux kernel community. If you are running a piece of infrastructure, right? If you're running, you know, Facebook, you can't be upgrading the kernel on Facebook every single day, right? So there's different people with different needs of how they utilize a piece of software in different settings, okay? And what the Linux community have done here, and what I'm going to do is I'm going to just get rid of this so I can illustrate this. They've created kind of a multi-pronged release model. And we actually went through, when I was at Canonical, we went through a similar set of challenges where, you know, we were releasing Ubuntu every 6 months. But there were various customers who come to us and say, you know, that's great because they get the hot new software every 6 months, but I can't be upgrading my infrastructure every 6 months. It's too time consuming, or it's, you know, it could be wasteful. Okay, so what the Linux kernel community have done is they've created kind of 4 different types of releases, and I'm going to illustrate this with a big triangle. Okay, 1, 2, 3, 4. Okay, so right at the top you have the RC releases, or the pre-patch releases. Now, this is essentially where version of Linux is available. You have to compile it. It's really designed just for kernel developers, okay? It's not something that's intended really for general users, but it provides a place where people can be on the bleeding edge of what's happening in Linux, okay? So this is primarily just for kernel developers to work with each other, okay? Now the next layer here is mainline, okay? This is where most of the feature development tends to be produced. This is where Linus Torvalds, he's maintaining this, okay? So this is kind of, again, bleeding edge, like there'll be a lot of bugs and issues and various other things that are going on in here. But what's nice about this is you can hook into any of these different levels. And the size here in the pyramid is the number of people that are likely to be using each of these different layers, okay? So not many people using the RC releases, and a slightly larger group of people are going to be using the mainline releases. But what happens is here, we then get into stable. Okay, and as you would assume, this is where a release of Linux is considered stable. It should be bug-free. Now, bugs always exist in software, but you should be able to get this and to be able to run it reliably. And this is where people will often use these stable releases in software that is going to be released on a semi-regular basis. So if Ubuntu, if they're releasing every 6 months, I'm presuming they're probably still going to be using these stable releases. And every 6 months you'll get the latest stable release that will go in there, okay? So if you're shipping updates to operating systems on a regular basis, let's say you're running some infrastructure and you do need to upgrade your operating system regularly, then you'll probably be using the stable releases. But there are going to be a bunch of people out there who cannot update their operating system very regularly, right? Because for whatever reasons, it's too risky, they don't have the staffing behind it, or they want to make sure that they're maintaining the same operating system release version so they can limit the amount of risk in terms of security issues and the kind of the testing burden to be able to deploy that operating system into production, okay? And I would argue that most people tend to, at least people who are running online services and people who are running massively deployed products, tend to fall into this category. And this is where this final stage comes in. And this is long term. Okay, so what happens here is there'll be a very limited number of long-term releases come out. They don't come out very often by design, and then critical bug fixes and security issues are then backported into long-term, right? So if somebody finds a critical bug in stable, right, what will happen is that individual bug fix will then be taken out and put into the long-term version, okay? So this means that a company like Facebook, who are deploying Facebook.com, could use the long-term kernel, but it means any of those critical security issues and bug fixes that are found in the stable version can then be merged into long-term. But if you're interested in being on the bleeding edge, right, if you just like digging deep into the Linux kernel community and you're learning how to be a kernel developer, then you're probably going to be interested in these two different layers here, okay? Alrighty, so, sorry this is a bit of a long video, but there was a lot to kind of get through. But these 6 reasons I think are fundamental in the success of Linux. Now, of course, there are not only 6 reasons, right? There are many, many other reasons why Linux has been successful. And what I'd love you to do is to go and put those into the comments, right? What have I not covered in this video that you think is important for viewers of this video to understand, okay? So go and pop those into the comments. What other reasons have defined Linux's success? I'd love to see them as well. One of the things I love about making these kinds of videos is I get to learn from you folks, and you're awesome, okay? Apart from you licensing weirdos, don't come after me, okay? We've had this conversation a million times before, all right? All right, now, make sure you hit that subscribe button, tap that little notification icon so you get updates with new videos, and I will see you on the next one.